here again. This is a video presentation in B6 AP Physics Group 1. We're going to talk about the theory behind Lab 9B, horizontally launched projectile. Okay. So let's kind of take a quick look and see what's going to happen in this video, or in this lab here. So the objective of this lab, objective is, we'll say to calculate, or we're going to say calculate where projectile will land on the ground. So calculate where the projectile will land on the ground if launched horizontally. Okay, so that's our objective. So literally X marks the spot. Okay, so objective. So now let's take a look here. Here we have some random height. Okay. It could be a desk. You can use one of those over there. We have various things to use over here. We have the one that worked last year was very popular, was using this track right here with a car like this. Or we have a marble you can use, like right here. Some people like using the marble like this here. Hold on, kind of go like this. Jeez. Oh. Okay, well, maybe not. Ah, man, holy cow. Okay. Yeah, so it shoots off here, project, So the use of these is so you get consistent velocity if you do several trials. Okay, so you can choose a couple apparatuses here to use. So we have a small group here. So a cart or an object is going to be launched horizontally. So we're going to put an object right here, okay, and right on the edge here, and it's going to have some initial velocity, VO. Okay. Now, even though the initial velocity is VO, what component is it? X. Yeah, it's VOX. So VO equals VOX because at the moment it leaves, it's just all horizontal. Okay. In fact, VOY is going to be 0. Okay, so figure out why is that 0. Because theta is going to be 0. Okay. At the moment it is launched, theta will be 0. Okay. Now, as a consequence, why is VOY 0? So if I go here, VOY, and I go equals VO times the sine of 0 degrees, what's the sine of 0 degrees? 0. So only at the initial moment it is 0. Okay. Now, as it leaves here, it's going to deviate and begin to take a horizontal parabolic path, like so. So after it leaves, it begins to gain y velocity in the y direction. So as it leaves here, it would kind of like this, 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 that, and finally like that. So it'll be the same thing as if I had a ball right here. Now, you ever see the video, like you watched the video where the guy launched it this way and dropped it? If not, there's a video I can put on there where a guy launches it this way and drops it and hits the ground at the same time. So here will be exactly the same. Okay, it's going to be 0. It's going to be kind of like here, get bigger, bigger, bigger. So this is going to hit the ground at the same time. So you drop an object or you launch it horizontally, even a rifle, you launch it horizontally, it may land 2 or 3 miles down the road, but the bullet will fall at the same rate as if you dropped it like that. Okay, free fall. Okay. All right, so VO is equal to 0, VOY is equal to VO sine of 0, which is 0. All right, so from here, what should we do? So I want to find horizontal distance. XO here is equal to 0, right? That's 0. Okay. and this is x. X marks the spot. Any suggestions of how I should approach this problem? Or what should I do? What's that? What's step one? Yeah, okay, you guys are kind of scaring me, man. Step one, determine VOX, okay? So, step one, determine, right, VOX, okay? Now, so that means, but however, we know that VOX is going to equal VO. So I have to get VO somewhere. And where do you think I can get VO? Yes, good. This is a photo gate. Now, have we used this in class yet? Not yet. Okay, I'll have to show you. So there's a laser in here. We measure the thickness of, okay, you remember the acceleration? Okay, I think we did. We did, okay, this is kind of sad, kind of scary. Half the class did not do lab number 4, which is the photo gate. It was a simulated lab. I think only my TA told me this morning only half the people did it. There was one. You remember, it was a virtual lab where there's a index card that goes through here. Yeah. Okay. Well, if you did, well, half the class didn't do it. But anyways, what happens is that you know the length of this. This is a laser timer. As it enters, it breaks the laser and starts the timer. As this goes through, when it passes through, it reinitiates the laser and stops the time. So this distance divided by the time it goes through here is your initial velocity. Okay, so we have to get this using the air links. If you had Portermeyer, you grab those air links that plugs into here and it hooks up to your iPhone or your Chromebook. Okay, so this is where we get the initial velocity. So we obtain initial velocity from photogate. From the photogate. So from right here, I'm going to go ahead and put in like a photo gate here. We'll call this photo gate. And that will give us our initial velocity. Okay? Now, once I have initial velocity, what should be maybe the next thing that I do? Okay, distance. Okay. Now, well, distance is where? Okay, is that more of a 2B? What's 2A? Flight time. Yeah, so 2A. Okay, so we want to do, in this case, we want to do step 2A, which is flight time. Okay, and I want to do flight time. So we're going to go ahead and go in here. So we can say y is equal to yo plus, what is it, VOYT plus 1/2 GT squared. Okay, so so final y is going to be 0. Okay, now how do we get yo? There's a hint. Should I probably use this? Yeah, probably use a ruler, and I would probably have to measure how high it's off the ground, right? Like right where it leaves the ground. So this will be my height. Okay, so using a ruler, meter stick. Okay, so we'll get yo from the meter stick. Yo, meter stick. Okay, cool. Now, what should our frame of reference be? What should up be? What should down be? Okay, in this case here, we'll take down to be positive because it's going horizontal or down. It'll be positive, up is negative. So therefore, G will have a value of 9.8 meters per second squared. Just makes the calculations easier. So we're over here, right, plus, right? This will be VOY, right? Okay, now, what's VOY? The answer is right here. 0. Okay. It's 0. Okay, are you guys just shy or really don't know what's going on? Shy? Okay, all right, shy. Okay, plus 1/2. We'll say this is going to be 9.8 t squared. Okay, so from here, do some math. Do some of my advanced algebra skills, right? Okay, it's going to be 2 times yo, right? So we want to solve for t here. So it's going to be what, the square root here. This will be what, 9.8? 9.8. or t, okay, or would it be yo? Is it 4.5, 4.9, 4.9 equals t. Okay. So there's my flight time, the square root of the height divided by 4.9. That's my flight time. Okay. So then finally, how would I get the x, Ryan? Yeah, exactly right, yeah. So now we go to step 2c, all right? So we go x equals VOX times the flight time. So you're going to calculate this, and believe it or not, lo and behold, if done correctly, whatever that says is right on. In fact, it's really cool to videotape the projectile hitting the X mark. So on the ground, you probably want to do an X mark. That's the X marks the spot. All right, that's the theory here, what you'll need to do for 9B. Okay, go ahead and stop here.